Okay, so what do you guys think? Is there a single transformation that can carry my pre-image onto the image? What do we think? No. Yeah, no was the correct answer there. So if we look at where B is located, where is it located on my pre-image? Top, bottom, side, pre-image. It's at the top, right? Where is it on my image? Good. So my three transformations that I can choose from, my three rigid motion. What does rigid motion mean and isometric mean?
Without changing shape or size.
Good. So staying the same shape or size. What are those three options that I have to choose from? Good. Please write that off to the side. Translate, reflect, and rotate. Remember, rotation is with a big R. I'm going to put that in parentheses. Reflection is with a little r, and then translation is a T. So those are the three options I have to choose from. What's the, or I guess there could be another one here, but what's like the most logical reason for the B being on top and now the B being on the bottom? Could be a rotation, but in this case, which one, if I'm just, yeah, just a reflection would be like the most logical answer here. So I know it had to be reflected or possibly like rotated 180 degrees, but something had to happen there. If I look at a reflection, let's go ahead and reflect. Which way should we reflect? Over the what line? Over the x-axis. Let's go ahead and do that. So I'm going to count up one for C, so I'm going to go down one for C prime. Okay, I'm going to go up 2 for A, so where am I going for A prime? Good. And then up 1, 2, 3, 4, down 1, 2, 3, 4. That shouldn't be new to us. So we still have congruent figures. Are they lined up on the same coordinates right now? Are they lined up on the same plane right now? Yeah, so that is what we wanted to do there. So we did, first of all, need a reflection over the x-axis. So I'm just going to write that like notation form. So we know we're on the right track, but we didn't have just one single one. It didn't fall or map right onto my image. What is my next one going to have to be here? A translation. Good. I'm keeping the same orientation. I'm not turning it. I'm not flipping it. I'm just sliding it. So let's go ahead and decide what my next step would have been. So let's just pick C prime 2. I'm going to name this C double prime. Okay, we use double prime, and I'll write that down for when we're doing multiple transformations. So how did I travel from C prime to C double prime? I went to the right, how many? 3. How would I write that? In notation form here, or in coordinate rule form. I'm going to pause here and let you guys try to write that down as a rule with your partner. Okay, so that's our coordinate rule there, x plus 3y. And then if we were going to write that in vector form, and you would know how I would change that to match vector form. Tyler, since you did it, what would you get?
Huh?
What would our vector form read or say?
I changed it to the
Oh, you change it to the other one? So you just take the numbers and plug them in here. So that's a positive 3. And what is that number? 0. So you do have to be able to recognize both there for a transition. So if there is not a single transformation that carries one figure onto the next, then we use a composite, or sorry, a composition of transformations. What do you think composition of transformation means? More than one. That's all it means. Good. So more than one transformation. So this should be mostly review today. We're just now combining. And you guys are a little bit ahead of my other class because we practice this a little bit on a Friday. All right, flip to the next page. Oh, these are some of Mr. Bird's quotes or jokes today. It's a good one, right? All right. So looking at our top one, and I'm just like right as kind of small as possible. because we're going to need all this room up top. So it says the pre-image w, x, y, z is given below. We're going to reflect it across, I like to say across y equals x, and then translate it with that coordinate rule, and it says to draw the image. So we're going to have two transformations here. My first one is reflecting across reflecting across y equals x. You should know how to draw that line, so draw that line. Draw that line. So the line y equals x should be that diagonal where all of your x values equal your y values. There are rulers in the back if you would like one. You do have to know that for the test. That's may not be drawn in for you. So it crosses right through our origin, and it is diagonal, my positive diagonal line. Okay, first thing I want to do is go ahead and write down or plot my points for w, x, y, z. So let's go ahead, I'll pause here and let's write down my coordinates. You have to have all these rules memorized. So right now we're reflecting across that diagonal line. The easiest way to do that is with the rule. Who remembers what you do with reflecting across y equals x? Have to know it for the test. It's not given to you. If you don't know, look back at your notes. You have that reference sheet with all four. Tyler, what'd you say?
Don't you like the x becomes y and y?
Yeah, you just switch your x and y. Just flip them. So we're going to flip my points. So my first prime, w prime, x prime, and let me pick a different color. W prime, x prime, y prime, z prime. All we're going to do is flip the point. Not the signs, we're just changing the x and y. So I'll pause here and let you guys do that. Okay, so remember you just flip your points there. So negative 3, 5 became 5, negative 3. And make sure they are labeled with a single prime. Negative 2 and 3, negative 3. There is always a way to do this if you don't if you don't remember that rule, which hopefully you will because we've practiced it a lot. You can always just turn your paper and go through diagonally. So that's another way you just don't get yourself stuck. If I start at the origin and go through diagonally to y, how many intersections did I cross through? 2, so I go the opposite way, and it should be 2 the other way. So you can always do that to double check yourself. Alright, so our next transformation tells me to do what? We're done with our first one. Now it tells me to translate. Are we going left or right? Are we going left or right? If it's just x, if it's just x,
You're
staying the same. And then where am I going? Up 1. So let's go ahead. We don't even need to draw the coordinates there. We're just going to move all of our points up 1. They are going to overlap a little bit. And we need to be using what's called double prime now because this is my second transformation. So all these should be double primes. Double prime. Questions there? This is really just taking what we learned last time and putting them together. So look at the one underneath. The only difference there, you'll notice I have the same pre-image. What's the only difference with this problem? What's the only difference with this problem and the last one?
It's flipping order.
Yeah, we're changing the order, right? It's telling me to translate first, so let's go ahead and do that. We're still moving in what direction? Up 1. So let's go ahead and do that. So let's move all of our points up 1. are going to need these points, so W prime, X prime, Y prime, Z prime. So double check me, but W prime is -3, 6, yes? X prime is -2, 7. Y prime is -2, 3. And Z prime is -3, 4. Do you guys agree? Alright. So we have our pre-image points. Now we're going to reflect it across that diagonal line. So let's go ahead and draw in that diagonal. There's our line y equals x. What do we do with those points to get our double primes? Good, we flip them. So I'll pause here and let you guys flip your points and graph it. Okay, so you should have two images there, a single prime and a double prime. The last question says, what do you notice about the image of W, X, Y, Z, so our double primes? What do you notice about those in each graph? So again, we said the only thing that changed there was the order that we did the transformations. So let's just test that theory. It says, what conjecture can you make? That's just a fancy word for observation. So let's decide if that order mattered. Did we end up in the same spot? So let's pick one letter. Which letter do you guys want to pick?
Y.
Y. Y is at 3, -2 on this image. Where was Y double prime here? We didn't write that down. Where is Y double prime here? 2, -1. Are those at the same spot? No, they're not. So what would we say our observation is? Does the order matter? Yes, it does. So the order of the transformations does matter. The order of transformations matters. Okay, so that is why it's important to notice which one they ask you to do first. Okay, moving on. Another joke. What's an astronaut's favorite part of the computer? You got it, Corey. The space bar. Okay. Up top. I'm gonna make this bigger. Up top is how we read these. Alright, so the symbol for composition is going to be that little open circle. So sometimes you'll see two of them put together with that little circle. That just means this is my first one, and that is my second one. My first one, that is my second one. So at first it tells us to translate what direction. If it's +1 and then +4. That should be quick, guys. Right 1, up 4. Good. And then we're going to reflect across the line y equals -1. Do you guys know how to find these lines? You are going to have to do that on your test. Like y equals -1, x equals -1. Those types of lines. Do we remember how to find those lines? They're either vertical or horizontal. So just think about where -1 is located on a graph. What direction do I go? Y. On the y-axis, where do I go? Down 1, right? So I would go down 1. Don't draw that because this is not this question. And it is going to be the horizontal line crossing through that point. Okay, I can't draw a vertical line because that's just the y-axis, right? So make sure it's just my horizontal line. Please write that down. So this one asks for x equals 1. Alright, so let's read this one. What would my order tell me to do here? Someone raise your hand. What does that first one tell me to do? Go ahead, Ashley. Rotate. Good to have a big R, and it also has degrees, which is a good hint. So this is going to be rotating how many degrees?
270.
270. If it's 270 positive, what direction does that tell me? Clockwise or counterclockwise?
Clockwise.
Remember, my negatives are clockwise, positives are actually counterclockwise. You do have to know that for the test. Positive numbers are always going to be counterclockwise. Okay, so is there an easier way to get to 270 counterclockwise? Corey, how do I do that? How many degrees? Good, so it's the same thing. Remember, that's our negative 90 degrees, which is 90 degrees clockwise. So first thing I want to do is go ahead and label my quadrants. So remember, we always want to match our quadrants. So positive, positive, what's quadrant 2? What's quadrant 2?
Positive, negative.
Negative, positive. If you don't know these, you need to have those memorized. And positive, negative. Remember quadrant 1, 2, 3, and 4. So let's go ahead and name these vertices. What do you guys want to name our image or our figure? We need 4 letters. A, B, C, D. So let's do A, B, C, D. Make sure yours are in the same spot as mine, please. Okay, we are going to need our original point, so I'll pause here and let's write those down. So remember the rule for rotations? You're going to match the quadrants, but what do I have to do with my x and y?
Switch them.
Switch them, right? So we're going to switch our x and y here. Or flip the point if you want to think about it like that. We're going to flip it. So I'm going to pick a new color for my single primes. And I know this is tedious, but it really does make a difference in the long run if you use your coordinates there. So first thing I'm going to do is literally ignore all the signs. I'm just going to look at the numbers and I'm going to switch them. So 4, 1, Devin is going to be what? If I switch 4, 1, it's going to be what? 1, 4. 1, 1. What's my next one going to be? 5, 2. 5, 3. So I want you to literally ignore the signs. Now we need to figure out where 90 degrees clockwise would take me. So going with a clock, right? How would this go, or where would this go? It's going to go up to quadrant. That's clockwise, right? Double check me. Going with the clock, we're going from quadrant 3 to quadrant 2. So we're going into the negative positive. That means all my x values need to be negative. Yes? Alright, so we're going to do negative, 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 negative. You guys good with that? Okay, let's go ahead and plot that point. Plot those points. So our next one is a reflection across the line x equals 1. So let's locate that line. That's not the x or y axis. How would I find, or where would I go for x equals 1? To the right one. Very good. So I'm going to draw a dot there. It is going to be the vertical line, right? I can't draw a horizontal line. That's just the x-axis, so I need to draw that vertical line. So I'm going to make a little note there. That's a vertical line. We're not going to do our coordinate points here. We're just going to use the graph. So let's just count away from that line. So starting at my line, how many did I go to the left to get to B prime? 2. So now I'm going to go right 2. And that's B double prime. That's fun to say. Okay, so go ahead and finish flipping your image there. So let's do M, A, T, H. And let's go ahead and write down our pre-image points. Right, so write down your pre-image points for M-A-T-H. Okay, so our first transformation tells me to do what? Our first one tells me to rotate. 180. Does it matter clockwise or counterclockwise here? It doesn't matter, so let's go ahead and rotate around the origin 180 degrees. Let's think about it logically. If I'm in the negative, negative, where am I going to end up for 180? Positive, positive. Very good. So remember, my rule just tells me to change the signs, which makes sense. All my negatives are now going to be positive. I don't want to flip the point anymore for 180. So what would m prime be? 4, 2. Very good. I don't want to flip it. I just want to change the signs. So 1, 2, 2, 5, and h prime would be 5, 5. Another way to do that, which some people prefer, just think we're going complete opposite. If I went left 1 and down 2, if I went left 1 and down 2, where would I go? Right 1, up 2. So some people prefer to do this all with the graph. So if I went left 2 and down 5, I'm going to go right 2 and up 5. Which I do sometimes also. Right 4, up 2. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Anyone know what this shape is?
A rhombus.
A rhombus. Very good. Okay. Do we have it graphed? Okay, so it almost again looks like a reflection, but that's a rotation 180 degrees. And then our last one tells me to do what? That's a little r. So that's a reflection over the line y equals negative x. We went through that on your reference sheet. Anyone remember where that line is? So remember the line y equals x was our positive diagonal line, right? That doesn't make sense here necessarily because it would be crossing through our images. So where do you think? It's my negative diagonal line. So it's my other diagonal. So let's go ahead and draw that. So it has the negative slope. You do have to be able to locate all of these lines for the EOC and for the test. Okay, so let's say we don't remember the rule for this line. We do know that I'm reflecting it back. So I've started here. This is my second. So you go in order. Now I'm taking this one and flipping it back across. So where do you think it's going to go? What quadrant? Back to the same one, right? Back to the negative, negative. So wouldn't it make sense that all of my coordinates would be negatives? Yeah, so we're going to think through that. So M double prime, A double prime, T double prime, H double prime. Let's go ahead and get our points ready. So I do know that they're all going to be negatives, just like logically thinking through that. And then what do we do for y equals x? What do we do for that rule? What did we do on the last page? We take those points and we do what with them? Shelby and Devin, I need you to stop talking. What do we do with those points? Flip them, yes? So we're going to flip these points and we know that they're all going to be negative. So really the rule here is I flip it and change the signs. Okay, I know this seems like a lot, but you guys are going to have to study over the weekend to remember all these rules. So I'm going to flip it across. I know that makes sense because I want to be in the negative, negative. And then I'm going to flip my not my pre-image, my single prime. So negative 2, negative 4. Okay, I'll let you guys finish this one. Reflection. So double check your answers there, but the coordinate rules really help. Okay, the last page, I'm going to zoom in a lot here. These are EOC type questions and really good test type questions that you may or may not see again. Hey. I would rather you wait till we're done. So looking at our first one, we can do most of this without a graph. You will be given a lot of graph paper on the test for my class and the EOC, so we'll practice that when we review. But it tells me the pre-image of SPOT has the following coordinates. It says we're going to reflect it over the x-axis. I want you to go ahead and underline that. This is a good example of like a word problem in geometry. So you have to have some reading comprehension skills. What do I know? What do I do when I reflect over the x-axis?
Change the y.
I change the y. I'm just going to write that down for myself. Change the y. Okay, just like help yourself out as you're working through this problem. Okay, that one's going to be easy. It says then I'm going to rotate it 90 degrees counterclockwise around the origin. Can I write anything helpful there? That's my second one. What do I need to know about the rule for rotating 90 degrees counterclockwise? What am I going to do with my values there? Switch. Good, we're going to switch them. So I'm just going to put switch there. I'm going to switch the x and y. So you want to just kind of help yourself out. So I'm going to pause here and let you guys figure out your primes, your single primes, and then we'll do the rotation together. So go ahead and reflect across the x-axis first. Alright, so make sure your reflection across x-axis matches mine. We know we're going to switch. I already saw some of you going through and switching them. Let's go ahead and do that. Ignore all the points. I'm going to pick, I should have picked pink there. I'll do pink again. So we're going to switch the point, ignore the sign. So 7-2 would become 2-7. So first thing I want to do is switch them. Next one would be 9-0. Next one would be 5-6. Last one would be 12-1. So my signs are all incorrect right now, or maybe some of them are correct. So we want to figure out now what quadrant they're going to match. If you do have a graph, that's fine. You could take these points. But like I can just simply draw a coordinate plane for myself right here and label my quadrants. So what's quadrant 1? Positive, positive. What's quadrant 2? Quadrant 3. And quadrant 4. Alright, so this is where I'm going to need your help because my brain starts short-circuiting when I'm talking about going different directions. So, let's look at my first column. Let's look at S prime. I am positive, negative, so what quadrant am I in? Good, so quadrant 4, right? I'm just going to kind of put a point there. If you're visual like me, like this really helps. Maybe some of you can do this without doing all of this. So I'm in the positive, negative. I'm going 90 degrees counterclockwise. So where should I end up here? I'm going counterclockwise.
Positive.
So I need to go back up to the positive, positive. So actually, we're good for that one, right? My answer was positive, positive. Devin, are you with me? You just sit up. Okay, let's look at the next one. Where is 0, negative 9 located? In the positive, negative. So what would that one also be? Positive, positive. So we're good on those two, actually. Let's look at our next one. We're in the negative, positive. So where am I? In the quadrant number 2. Good. So I'm going to put a point there. Negative, positive. I'm going counterclockwise.
Negative, negative.
Negative, negative. So negative 5, negative 6. Okay, and the last one, I'm in the positive, positive, and I'm going counterclockwise to the negative, positive. So that's just a little trick there that we can use. Questions? So we did that all without a graph. You could obviously use a graph if you wanted to. Okay, let's move to this other number one. So it says point P double prime is negative 9, 0. I'm just going to kind of make myself some notes as I'm looking through this. Okay, a lot of the geometry EOC is like a reading test. Sometimes they're long questions, and that's the hardest part for some people. Okay, so that's one of my points. It says the original image was rotated 90 degrees clockwise and then translated with that following rule. I'm just going to write that off to the side. So 90 degrees clockwise, not counterclockwise, clockwise. And then also I had a translation. X minus 8, y plus 5. You could also just underline these things. I'm just like pulling out the important information. Okay, I'm kind of just making this word problem a little bit easier. So it gave me double prime, but look what it's asking me to find. What is the question asking me to find? The original, which is our pre-image, right? So we're looking for P just on its own. But we have gone through how many transformations? 2 to get there. So this would really be my P prime, and then afterwards, this would take me back to my original. So we're really looking for that last one here. So one way to do this, I could take my pre-image points. You could take every single one of these and plug it in and do them. Okay, or we can work backwards. I'm going to work backwards because that just seems like a little less work. But if that's like stressing you out to think backwards through these, then just take each one, like always, don't get stuck. Take each one and plug them in and see which one would take me to -9, 0. So we're working backwards, which means we are going to do the translation first. I'm not looking for my image here. I'm going backwards. Sorry, I can't speak. I'm going backwards. So I'm going to take my point and I'm going to not plug it in. I'm going to do what? Set it equal to. So I'm going to do x minus 8 equals -9. I'm solving for my pre-image point. Do that. Again, that should be easy by now. Okay, when I add 8 to both sides, Corbin, what would my x value be? I'm just solving for x. So what is my x value there? Not 0. -9 plus 8 would give me -1. So my x value for p prime is -1. Okay, again, we're working backwards, so we're setting equal. So I'm going to do y plus 5 equals what? 0. And that is just going to change the sign. So y equals -5. So we have my single prime. Now we're working backwards. So I'm going to use this little graph over here that I already did, if you don't want to draw a new one. So right now my point is -, correct? So I'm going to pick a different color. I'm in the -. Okay, it told me that I rotated it 90 degrees clockwise, but I'm going backwards here, so which way do I need to go now? Counterclockwise. So I need to go counterclockwise, which would not be this way, right? It would be back that way into the what? Positive, negative. So my answer should be positive, negative. And then what do I do with rotations of 90 degrees? I flip them around. So this should be +5, -1. So what is my answer there? D. So you kind of have to think backwards there to get there. Does that hurt your brains at all?
No.
If you didn't do, or if you couldn't do that, again, you could take each one of those and just work them out going forward like normal. Okay, so let's look at our last two. Okay, this one says, consider the figure below in the following rotation. Rectangle path is rotated 270 degrees counterclockwise. Let's rewrite that. How can I rewrite 270 counterclockwise? -90 or 90 degrees clockwise. Okay, and then reflected across the y-axis. Let's go ahead and just highlight the y-axis so we don't get confused there. So we are rotating it 90 degrees clockwise and then reflecting across the y-axis. It says Tatum argues that this image created above will be the same as the pre-image. So he's thinking it's going to look exactly the same and fall right back on my pre-image. Marla refutes the answer by arguing that the images will not be the same. Who is correct? So we're trying to figure out, is it going to look exactly the same as the first one? Aubrey, I need you to sit up. Aubrey, I need you to sit up. Okay, so if let's think about this logically. If I rotate it 90 degrees clockwise, where's it going to go? Right, we're going back over here, but it's a rectangle, right? So if I'm rotating it 90 degrees, what's it going to look like? It's going to be turned on its side. Okay, if I now reflect that across the y-axis, is it still going to be on its side?
Yeah.
If I now flip it this way, is it still going to be laying on its side? Yeah, it is, but it's just going to be going this way. Are those going to line up exactly? No. So that's not true. We'll decide who's correct in a second. So that's one way to do that. You can literally just think that through logically. Like that literally told me my answer. But let's say you didn't want to think about it logically or didn't know to do that. Pick one point. So let's pick A, and let's just do that. So my pre-image point is -2, 3. If I'm rotating it 90 degrees, we know it's positive, positive. And what do I do with my point? Flip it. So this would be 3, 2. Let's go ahead and graph that. 1, 2, 3, 1, 2. That's A prime. Now I'm going to reflect it across the y-axis. So what am I going to change here? When I reflect across y, I change the x. So -3, 2, -1, 2, 3, +2. Did those line up? No. So we know that they did not line up, so who would we say had the correct answer here? Marla. So Marla was correct because we can say rotations change the orientation, which means it changes the way it's facing. Rotations flipped it on its side, so it's not going to match anymore. The only rotation that would have worked there would have been, anybody know? 180? That would have still been the same. Alright, last one. Last one. Consider the polygon after the composition of transformations represented by the dashed lines below. So it's telling me my pre-image is the one that's solid, and this is after 2 transformations. You're given 4 different options. Best way to do this, process of elimination. So let's notice what's going on at first anyways. What's one that we can already eliminate? My 3 are translation, reflection, rotation. What's one that we can really just eliminate? B? We don't know. I'm saying out of those 3 options, translation, reflection, rotation, which one would this not be?
Reflection.
Could be a reflection. This, for sure, is not a rotation of how many degrees? 90, because it would put it on its side, correct? So do you see anything that says rotation of 90 degrees? C. So let's mark out C. So always kind of assess the question first, mark out any that we know it's not. It could have been a rotation of 180, but that's not an option. So if we don't know, then we're just going to go through each one and use process of elimination. So we're going to pick one point, and I'm going to pick this corner. And what do we want to name it? A. So I don't have to do the whole thing, just pick one point. Okay, my first one tells me to reflect across the x-axis. We can do that, right? So let's reflect it across the x-axis. I went up 3, now where am I going? Down 3. There's A prime. Now it says I'm translating it what direction? What does that tell me? Right 7 and up 1. So let's do that. 1, 2, 3, 4, 5, 6, 7, up 1. Did I land on a point? Yeah, which would make sense, especially when I reflect it. A's on bottom, now it's on top. But we're going to put a little question mark there because we always want to check the other ones. Definitely. Okay, my next one, which is really good practice, is a reflection across y equals 1. Where do I find that line? Up 1. Is it horizontal or vertical? Horizontal. So, let's reflect it across that line. How many did I go up from that line? 2. So now I'm going to go down 2. And then what does my next part tell me? Move over 7. Am I going to land on a spot? No, I'm not. So that one is wrong. Let's hope that the last one's wrong as well. What does that translation tell me to do? Move over 10. And then we're going to reflect across there. So translating to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I reflect that across my diagonal negative line, where's it gonna go? Right now it's in the positive, positive. Where's it gonna go?
Negative.
Negative, negative. Is that correct? No. So my correct answer was
A.
A. But you always want to double check. Okay, that is our notes for today.